Hello students, today we'll discuss about the 8051 microcontroller interfacing. In that, first of all, we'll discuss about the interfacing of memory, both ROM and RAM, how it can be interfaced with the 8051 microcontroller. Friends, to begin with, for interfacing, we need an octal latch 74LS373. Here you can see that on the screen, because we all know the lower order address data lines 80 to 87 of the 8051 microcontroller are multiplexed. So in order to separate the address and data lines, first we need to demultiplex it, and that can be demultiplexed using the octal latch. Here you can see the ALE signal that is used as address latch enable going to the enable input of the octal latch. Because of that, you will find here A0 to A7, all the address lines are separated from the data lines. Here you can see the D0 to D7 data lines. Okay? So such 8 D flip-flops that are used internally in this octal latch. This is very important supporting chip used in the interfacing. Similarly, you need one more interfacing chip, and that is called as the decoder. For address decoding, mostly 74LS138, that is the 3:8 decoder. You can see that on the screen, that is used. Here for this decoder IC, there are A, B, C are the 3 inputs, and Y0 to Y7 are the active low outputs. Here you can see the function table for this decoder. Depending on the ABC input, corresponding output line that will go low. Low means active. So in this table, whatever is shown in the red box, you will find that whenever ABC inputs are all low, Y0 signal is going low, that means selected, and remaining all are at high. Similarly, from Y0 to Y7, here you can find all the ABC are 111 high, and that means the 7th output, that is Y7, that is going low. So in that case, the Y7th will be selected. So starting from 00 to all 111, the corresponding output that is selected at a time. And for this decoder, there are 3 enable inputs, 2 are active low and 1 is active high. So that is used for chip select logic in the various interfacing chips. For all, whether it is a memory or input output devices, you need a chip select signal. Now here it is shown how the demultiplexing is done using the octal latch. You can find 8051 chip here, the ALE signal, address latch enable, and then the port 0 lines where the multiplexed address data lines are available. So the separate address and data lines you will get at the end. One more thing, remember that port 0 and port 2 of the 8051 is used for address data purpose in the 8051 microcontroller. Whenever they are not used for, say, parallel data transfer, input output, that time they are used as a address data lines. ALE signal, during the first part of the machine cycle, the ALE signal goes high. That indicates the address is available on this common bus, and hence A0 to A7 that is latched, and later on the same bus is used as a data bus. Now we'll go for memory interfacing. First, we'll discuss about the program memory. You know, in the 8051, there is a 64K program memory space and 64K data memory space. Now here, in general, how to interface the program memory with the 8051 microcontroller that is shown. There you can see the port 0 and port 2 lines used for address data purpose. Port 1 is a simple bidirectional port, and from port 3, the read and write signals are used in case of interfacing the RAM. Since we are interfacing the EPROM, PSEN signal, or as the program stroke enable, that signal is used as a read stroke for reading this read-only memory. One more important point you should note that since we are accessing the external program memory, you know there is a internal as well as external program memory. In the 8051, here whenever we connect EA signal to the ground, that means we are accessing the external memory. Okay, so that is shown here. Similarly, we can interface the RAM. Next, here you can see the general interfacing for the data memory, the RAM, read-write memory. Since it is a read-write memory, you can find here the read and write signals from the port 3 that are going to the write enable and output enable of the RAM. The remaining things are same, demultiplexing the data and address lines. ALE is used as a latch signal, stroke signal to the latch, and you can access the memory for read and write purpose. That is the general interfacing for EPROM and the RAM. Next, we will see when a specific size that is specified, then how to interface that memory chip. For that, we all know that first, depending on the memory size which is specified, you have to select number of address lines that are to be used to access the memory locations, the entire memory space of that chip. Say if it is the 1 kilobytes of the memory size, then you need the total 10 address lines, A0 to A9, to access that 1 KB. Similarly, for 8 kilobytes of RAM, you need the 13 address lines, A0 to A12. If it is the 32 KB ROM, you need a 15 address lines, A0 to A14. So, depending on the size of the memory chip, you need to select the how many number of address lines are to be used for accessing that memory chip. Remember, the remaining higher order address lines that are used for chip select logic. So from this table, you can easily remember. You can see here, it is doubling 1K, 2K, 4K, 8K, 16K, 32K, and 64K. And simply, you can remember the starting point. For 1K, 10 lines are required, and then 11, 12, 13, 14, 15 onwards up to 16. So for entire 64 kilobytes of address space, you will need all the 16 address lines. Well, once you remember this, it is easy. While designing the memory interface, first you need to find out how many address lines are required. Then you need to draw the memory map showing the starting address and end address, and then draw the design. Now here, for example, let us suppose 8 KB EPROM that is to be interfaced with the 8051 microcontroller. The chip is 2764. Now this 8 KB EPROM means how many address lines will be required? 13. So A0 to A12 address lines that are used for accessing the memory chip. Here you can see the octal latch that is used for separating lower order address and data lines. The data lines that are connected to D0 to D7 of the memory chip, and higher order address lines from the port 2 you can find here, A8 to A12, that are used here for accessing the memory. However, the remaining lines 13, 14, 15 that are not shown, that are kept open disconnected. Since this is the EPROM, PSEN signal you can see here is used for read stroke, read only memory. So that is going to the chip select and output enable of this EPROM chip, right? Here you can find the two signals, read and write bar, that are not connected. And once again, EA bar signal is connected to ground, showing that we are interfacing the external memory. Well, that is how the EPROM is interfaced. Same, let us see how the RAM is interfaced. Now here 16 KB RAM is shown, data memory. For 16K, how many address lines will be required? 14. So A0 to A13 address lines are shown here, going for accessing the memory, and again separating the address data lines using the demultiplexer octal latch. Then we can find the PSEN is left open here because is the read write memory, so we need the read and write signals. So for read operation, the read signal will go active, going to the output enable of this, and during the write operation, the write signal will go active. Okay, and let us see how the chip select logic is used here. Using the higher order address lines A13, 14, 15, sorry, A14 and A15, the chip select signal that is generated. Here you can see the input to the AND gate is from A15, and after inverting the A14. So A14, if it is 0, then it will be 1, and A15 should be 1. So starting address here is selected as a 8000 since A15 is 1, right? So you can keep any starting address, right? That depends on the designer, right? So when both the inputs are 1, the output of the NAND gate will be 0 and chip will be selected. That is how the read-write memory RAM that can be interfaced. Here we are using gates, different logic circuits for chip select logic. Now, after this, let us see how both RAM and ROM that can be interfaced with the 8051 microcontroller, because in the microcontroller based system, both RAM and ROM has to be used. So when both chips are to be interfaced at a time, here it shows the entire design as I told earlier. Because the ROM is 16K and RAM is 32K, you can find here for 16K ROM, total address lines used. Memory map is shown here. From A0 to A15, you have to write the address, and starting address is taken as a 0000, and you can see up to A30. So starting from 0, 1, so all bits, when all bits are 1111, the address will be 3F. That is the end address for this EPROM, right? Similarly, for 32K RAM, there it shows the memory map where you can find, as I told, now here what is done, A15 line is permanently kept high. So the starting address is 8000 as we had seen in the earlier example. And here the remaining lines from 0 to when all was 1, the final end address will be H. So that is how the start and end addresses for accessing that particular memory chip that can be found out. Now we'll go to the design part. Here again 74LS373 is used for demultiplexing purpose. ALE is for latching purpose. So port 0 lines and then the port 2 lines. In the port 2 you can find for this EPROM total A0 to A13 that are used, right? 14 lines for accessing the 16K EPROM. And now see the chip select logic for this. So what is done using the OR gate, the higher order address lines P2.6 and 7 and along with PSEN signal they are OR, and then whenever the PSEN is 0 and both of these are 0, then only the chip will be selected and a read operation can be performed. You can see for RAM from P 3.6 and 3.7, the read and write signals that are used for read-write purpose, right? That is shown here. Now for RAM is 32K. So how many address lines are needed? From A0 to A14. Total 15 address lines will be required for 32K that are shown here. A0 to A7 from port 0, A8 to A13, and here A14 is shown, right? Now the A15 is used for chip select, that is coming from the 2.7 pin, right? So that is how the chip will be selected when P2.7 that is low. For rest of the cases, the RAM will not be selected, right? So that is how the RAM and ROM both can be interfaced with the 8051 microcontroller. EA signal is connected to ground, ESS, right? So accessing the external program memory and the data memory. Now we'll see the example where 74LS138, the decoder that is used. Here you can see decoder that is used for chip select logic, and there is a octal latch. In this interfacing, one data memory, RAM is used 16K, then data ROM 16K, and program memory 16K. Okay, the program memory EPROM is used for storing the code. However, for data memory, the data that can be stored in this 16K data ROM. Now here we can see how the chip select logic is designed for this. For EPROM, no problem, the PSEN signal as it is, that is used for chip select logic. However, for this data ROM, you can find that the read signal from P3.7 that is used as a read signal, read stroke. It is going to the output enable of the data ROM. So to perform the read operation. Okay. Now for chip select, what is done? The Y0 output of the decoder that is used. That means whenever the A, B, C, all the three inputs are 0. Here you can see in the decoder, this is grounded, and A and B, 14 and 15, when both are 0, then only the Y0 signal will go active and this chip will be enabled. Now here the second chip select signal that is generated using the Y2. Y2 means the signal, that is what should be the input for ABC? That should be, say, 2, means 0, 0, 0, then 0, 0, 1 and 0, 1, 0. So whenever this 15 line will be 1 and this is 0 and this is 0, then only the Y2 output will go low and the chip will be selected, right? You can use any output between Y0 to Y7 for chip select. Like that, total 8 chip select inputs you will get from 174LS138, right? Maximum 8 chip select signals you may obtain from one 3S to 8 decoder. If you need more, you need one more decoder, right? So that is how this 74LS138 decoder is used for address decoding logic to enable the chip, to select the chip, and here again the octal latch that is used for demultiplexing purpose, separating the lower order address and data lines. EA bar signal is again showing connected to ground. though it is shown 8031, 8031 and 51 both are same, similar microcontroller chips. One more important thing is that you need this for octal latch and decoder for interfacing the input output devices also, because only having say memory is not enough. You need the input output devices when you have a microcontroller based system. So that will be having the input devices, output devices, and the memory, RAM, ROM, both data ROM and the read write memory, right? So whenever we are accessing the external memory, that is how you can interface the memory chips with the 8051 microcontroller. So what are the design steps? First, you need to identify how many address lines will be required for given memory size. Then you have to draw the memory map, start address and end address for the chips. And then you go for the design. You have to design for the chip select logic using the decoder or using the logic gates. And like this, you have to separate the address data line. So very simple. Thank you. That is the end of today's session.